Hello and welcome to EGN 3613. In this session we will address interest formulas for single cash flows. And they are not different than the other formulas that we were using. It's the same formula, but we will understand more how could it be used in our daily life. The first formula, which is the one that we were using always, which is F is equal to P multiplied by 1 plus I to the power N. And this is called single payment compound amount factor or growth factor. So it's compound amount factor, which is the 1 plus I to the power N. So the 1 plus I to the power N, we consider it as a factor that will affect the P. So this is our factor, which will be F multiplied by P will give me the future value. So we call this as the growth factor or the compound amount factor. We can find that, as we learned before, using the formula, the mathematical calculations, as we learned in the previous examples. We can also write it differently. We can write it as future value is equal to P multiplied by that factor, and that factor can be given or can be found from the book, from the tables that exist in the book at the back of the book. And I will teach you how to do that in a minute. But how can we read this expression? This expression is read as I need F given, so this slash means given P. So we need the future value given the principal with the interest rate I and number of periods N. Again, this can be read as an expression, which means we need F given B, P, the principal, having interest rate I over number of periods N. Now let's look at some examples. If you had a 2000 now and invested it at 10%, how much would it be worth in 8 years? So we have the interest rate, which is 10%. We have the number of periods, which is 8. And we have the current investment or the principal for today, which is $2,000. Given the formula that F is equal to P multiplied by 1 plus I to the power N, then P is 2000 as given by the question or the problem that we have, multiplied by 1 plus, and the interest rate is 10%, so it will be 0.10, all to the power N, which is in this case 8. So this is my equation, and as we used to do it, we can just calculate and find the value from that. So the first way is just to do the calculation. And if we want to do the calculation, we'll find that the value is 4,287 and 18 cents. So this is the first method. The first method is to do normal calculation using the calculator. The second method that we talked about was the Excel sheet. And we use the Excel sheet we have P which is equal to 2000. We have I, which is equal to 10% or 0.1, and N, which is equal to 8 years. And if we would like to find the value of f, the future value, we can again use the mathematical method, which is 2000. We can say that this will equal to 2000 multiplied by 1 plus the interest rate all to the power n, and that will be the value, which is the 4287, and we can actually make it 2 decimals, so we can use 2 numbers, and that will be approximately 4,287 and 18 cents, and this is the value that we are looking for. So this is a way, either using the mathematical calculation using Excel, or there is another way within Excel that we can do the value. Now let's do this. In Excel, f is called future value, and it has a function. So all what I need is to say that this equal to fv, and that will give me the argument for that one, which is future value, and the future value here will equal rate. So it's giving me that I need first to put the rate, which is the 10%. So we'll put the rate, and that's 10%. Or I can use this cell here, comma, for the number of years it's 8. For the payments, we don't have yearly payments, we are not talking about payments here, so we'll leave it empty. We can put a 0 instead of that, and then the present value, which is 2000, and the type, as you can see here, it's giving me that if it's 0, it's end of the period, and that's most likely what's gonna happen, that it will be paid at the end of the period, or 1 at the beginning of the period. So we can change it between end of the period or beginning of the period, end of the year or beginning of the year. And in this case, we'll put a 0 and then close the argument or the expression, and we will get the same value, which is 4,287 and 18 cents. So using Excel, we can either use the mathematical calculation that's been done over here, or you can use the built-in function for finding the future value. So now I have 2 ways of calculating the future value, either using the mathematical or using the Excel sheet with the built-in functions. Let's learn a third way to find that. What will be the third way? Now remember that I'm saying that this is called the growth factor. So I can actually find that factor from the book. So we'll open the book on the table that says 8%. So selecting the interest rate 8% and then going to 8 years, and this is 8 years, the period, we can go to F given P, and that's the first one, which is the 1.8509, and once I substitute that with the value factor multiplied by 2000, you will get the 4,287 and 18 cents. And as you can see here, the F given P with interest I and number of periods N, and that is called the compound amount factor. So looking at the table at the end of the book, you can see that these values can be given and the factor can be multiplied by P, and that will give you the future value for that equation, or that, which means now it can be calculated in three different ways. The first way is the mathematical calculation. The second way, which is using the Excel sheet, as we learned before, and the third way is using the factor, or calculating the factor from the tables in the back of the book and multiplying that with the p-value to get the future value. So those are three different methods of calculation for the same value. The second formula, which is again, it's just a different form of the first formula. So this is not a new formula. This is not a new formula. It's the same formula that we used before, but it's been written differently, where we moved P to one side and F to the other side, or actually we divided by 1 plus I to the power n, which is, if you take it up to the numerator, it will be to the minus n, and that's the only difference. In this situation, this factor is called the discount factor. And again, you can find this discount factor at the end of the book from the tables. It depends on the interest rate, so you open the book at the specific interest rate table, and then select the number of periods, or based on the number of periods, select the factor. You multiply that by the future value and you get the present value. So given interest rate I with 12%, N with 5 years, and F with 1,000, calculate the present value, or the current value, or the principal value that you need to invest today, or you need to deposit today. How do we do that? Again, we put the 1,000, which is the 1,000 represents the future value, multiplied by 1 plus I, which is 12% in this case, all to the power minus 5, and that will give us a value of 567.40 cents if we calculated that through mathematical calculation. The second method is using Excel sheet, and the third method is to find the factor of P given F. P given F with 12% rate and 5 number of periods. And if you look at the table, again, you will find that with 12% and 5 number of periods, the factor is 0.5674. Multiply that by 1,000, you will get 567.40 cents. Another practice problem, if you want to set aside a lump sum amount today in savings account that earns 7% annual interest to meet a future expense in the amount of 10,000 to be incurred in 6 years. How much do you need to deposit today? So we would like to find the present value given 7% interest and future value of 10,000 over 6 years. That means n over equal to 6. We apply the formula. Then P is equal to the future value, which is 10,000, multiplied by 1 plus 0.07 to the power minus 6. And again, you know why did we put it as negative? Because it was in the denominator and we moved it up to the numerator. Okay, the other way is finding the factor for P given F with 7% and 6 years, and that will be multiplied by the future value, the total amount for P, or the present value that you need to deposit today is $6,663. $6,663. In some cases, we have multiple payments. So you deposit or you withdraw today a certain amount today, and then you would like to make payments, multiple payments. Or if you deposited amount today, you would like to withdraw it over 3 different payments. How would that work? In this case, we have a P amount that was deposited today, and there will be a withdrawal of 25,000 after year 1 or at the end of year 1, 3,000 at the end of year 2, and 5,000 at the end of year 4. Since this is an uneven payment series, what could be done in this case is taking each deposit or each payment separately and bringing the P value to that one to today. So 25,000 brought to today, it was equal to 22,727 with our calculation. Now remember that we are doing 1 year only, and the interest rate is 10%. For the 3,000, actually it was after 2 years, so we bring that back. This is the future value. We use the formula, giving the future 3,000 with 10% and 2 years, we'll find the result will be 2,479. For the third one, the same, the future value is 5,000, but it's after 4 years with interest rate 10. We replace the values and find that P3 is equal to 3,415. So here now we have P1, we have P2, and we have P3. So P is equal to the summation of these 3 present values or principal values. That means that P is equal to, adding all these values together, this one, and this one, will equal to $28,622. And this is the amount that we need to deposit today to be able to get 25,000 the first year, 3,000 the second year, and 5,000 the fourth year. And you can actually check on the balance over the years with the interest rate and the payment. You can check that, and you can see that it's negative, positive here, and the payment in negative. Or you can assume that this is out of your pocket, this is for the bank. You can assume that this is out of your pocket, so this is negative and this is positive, positive, positive. Whatever you like to calculate it as, either from your pocket or actually as into the bank, inflows to the bank, it's fine. The most important thing is to know that which one is the inflows and which ones are the outflows. So back to our terminology and symbols. The P is equal to value or amount of money at time designated as the present value or present time at time 0. That's why we call it P. Sometimes they call it present worth. So you will see that in the book or other books that they are calling it present worth or present value. So whether it's PW, present worth, or present value is the same as the P that we studied. It's not nothing new. It's not nothing that's being created new. The same value. It can be called net present value, MPV, or it can be discount cash flows, DCF, or it can be capitalized cost. So any of these values are the same or equal to the P value. It's the present value or the principal value. Another terminology is the future value or F. F is the value amount of money at some future time. Also F is called future worth or FW or future value. So you can see it in different occasions. That is called future worth or future value. And all these values are measured in dollar. One of the things that you will learn later on is the A. And A is a series of consecutive equal end-of-period amounts of money. End-of-period amount of money that's being paid. Either paid back or paid for you. It's paid out. So also we can actually call it as the annual worth and equivalent uniform annual worth, and all these are measured by dollar. It can be per year, it can be per month, or it can be by other measures. The most important thing is that the number of interest periods are the same or are equal, either years, all of them are years, or all of them are months, or all of them are days. We cannot mix periods or different periods together. And of course the I, the interest rate per time, period of time, which is the percentage per year or percentage per month. It depends on the period, and that is the interest rate that we'll be using during the semester. Another one that you will see is the time, T, which is stated in periods. So you will see that the time T is stated in maybe annually, monthly, daily, or weekly. It doesn't matter. It depends on the type of question or type of problems that we are dealing with. So those are the terminologies. Those are the most important equations, or it's one equation that we are dealing with just to find the future value, present value, the interest rate, or the number of periods. But we are talking about mostly we were talking about single payment. Even when I talked about multiple payment, I brought all that, I broke it into pieces and brought it back to the present value and calculated the present value. Other things will be learned in the next series of lectures, where you can see that we have now annuity, annual payment that has to be paid back or has to be withdrawn to achieve certain future value or certain present value. That will be all for this session. If you have any questions, you can email it to me. Thank you and have a great day.